The equation has to have x squared, y squared. Yes, it can have different situations like x minus h, everything squared if it's shifted, divided by a squared plus y minus k, everything squared divided by b squared, but 1 still has to be here. Okay, so we normally look at ellipses that are that have the longest axis, the major axis on the x-axis or the major axis on the y-axis. So something like this. Okay, so in this case, because this number is bigger than this number, then we have here -3 and +3, the square root of that, positive and negative. And we have here -2 and 2, this point. So this is the major axis and the minor axis. And that's all. So I don't remember the exact problem, but I'm assuming that was a situation like this in which you can also graph. Let me share my screen for a second. And let me see, under apps, you should be able to see conics. Not all calculators have this, however. So under conics, you have the option of an ellipse. And it's asking you if it's shifted or not. And in this case, I will enter A as being 9, just 3, because it will square it automatically. B as being, in my case, 2. Age and being 0 because I didn't shift, and K being 0. And let's see if it's graphing it. And you see it here. Okay? And so under apps, so it won't let me go back to apps. Okay, so here it is. You have the circle, the ellipse, the hyperbola, and the parabola. The parabola that opens either to the right, which is not a function, or to the left, which is not a function. Okay, anything else? Do you have other questions for me? Anything you'd like me to go back to? Anything?
I have a question.
Yes?
When I was doing the homework problems, I was kind of struggling with the implicit differential.
Yes, so can you choose a problem? Let's work on any problem. I am assuming that you are redoing the problems we do in class. You have the videos and that will really help you if you get into the habit of doing that. Yes, I'm ready. Any problem?
Okay, it was sine x cosine y equals x squared minus 5y.
Okay, so I normally write solutions after class, but this time I also prepared the video for you. So when you differentiate the left-hand side, you have sine prime, which is cosine times cosine, plus sine times cosine prime, which is negative sine y, times the inner function prime, which is dy over dx. On the other side, we have x squared, which is x prime. X squared prime is 2x. You copy -5, and you differentiate y, which is dy over dx. Now, all you need to do next is rearrange. So I will bring 2x to this side, because these two terms do not have dy over dx. And I will bring this term that will become negative sine x sine y, but it's negative when I move it to the other side is positive. And I will factor out dy over dx. So then dy over dx is this quantity over this quantity. And that's all you need to do for this problem. Is this good enough? You want to choose another, Gabriel?
Yeah, well, I guess I'll find another one so you could like walk through it.
But what was the problem? Can you point out and say this or that?
I would say like maybe it's just the chain rule. I have to practice more. I guess that's what it is.
So what I recommend I always recommend that. So we had all these problems. Have you tried those? So this was one, Here's the same one. Yes. Here's the second problem. Here's the third problem. Have you tried these first? And here's the fourth problem. Have you tried these first? From
Yeah,
last.
I watched the lectures. It just like I don't. It wasn't like clicking.
Okay. Do you want to choose another?
Oh, I mean, I only have the ones from homework, so I guess I'll find them on the
But that's the problem. If you only do the problem from the homework, that's not going to be enough. That's my point. Okay, anything else? Okay, so you want me to do something else? Is there something that I should do? I see that some of you still have problems. Does anyone want me to do anything else? Anyone?
I think we can move on.
So this was written in a very fine pen, so that's why you probably couldn't see very well. But when I post this, this is going to be very clear. So you want me to do the same problem? You want to choose another problem? You want me to choose another problem? Regardless of how many problems I solve, if you don't try step by step yourself, it may not work. So would you like to choose another, or you want me to choose another, or how do we proceed? Anyone? Yes, Gabriel, you want to
choose another problem?
Okay. So you want me to choose another? Okay. You have one for me?
No.
Okay. So let's say I'm going to choose e to x divided by y equals x minus y. Is that okay? Is this a good one, or should I choose another, or is this okay?
I think it works.
And then after this, can we do a more complicated example of one?
Okay, just give me any example that you want to work on.
I don't have any examples that I want to work on.
So you think that this is an e?
Well, like a more complex one with a lot more like values on each side. Just making it a bit more complicated, because those are the problems that we get in the actual book, and those aren't the ones that we go over in class.
Okay, you want to choose one from web assigned then?
I mean, someone else can, or you can.
So I guess this is not a good one. Okay, so what about this one? E to y cosine x equals 1 plus sine xy. Is this a good one?
Yep.
Good. So we differentiate both sides. So the left-hand side is a product. So e to y prime is e to y times dy over dx multiplied by cosine x. Is this okay, everyone? Can you see now? Is this clear now?
Yes.
Okay. So then plus e to y. Now I differentiate cosine x, which is negative sine x. Is the left hand side okay?
Yeah, that's the product rule with the other one mixed into it.
Yes, the chain rule. Very good.
Yes.
So now the right hand side, I have to differentiate sine, and I get cosine xy, but I have to multiply by the inner function prime. The first function prime is 1, so this is y, plus x times the second function prime, which is dy over dx. Is this okay?
Yes.
Okay, perfect. So now I see 2 dy over dx, so I have to have them on one side and everything else on the other. But before I do that, I will have to rearrange it. So I'm going to rearrange everything as e to y times cosine x times dy over dx. Here I'm going to write negative e to y sine x. Here I'm going to distribute to these two quantities. So I have y cosine xy and plus x cosine xy times dy over dx. Is this clear enough for everyone?
Yes.
Okay, perfect. So now I will bring this term to this side and this term to that side. And at the same time, I will factor out dy over dx. So this is my page 2. So then I have e to y cosine x. This becomes negative minus x cosine xy. Everything multiplied by dy over dx. And then the other side is e to y sine x plus y cosine xy. And finally, we have dy over dx. Can anyone tell us what to do here?
So you divide by like everything in the parentheses.
Exactly, very good. Thank you. Who said that?
Gabriel.
Good. So everything is better then?
Yeah, it's slowly getting better.
Okay. This is it. Perfect. Okay. We looked at some examples with the inverse trig functions. I would like to talk about orthogonal trajectories so you have an idea of what that means. So, orthogonal trajectories. So we say that two functions are orthogonal if at every point of intersection their tangents are perpendicular. So two functions are orthogonal if at all points of intersection, their tangents are perpendicular. Now, families of functions are orthogonal if at any point of intersection their tangents are perpendicular. So let's look at a situation like, let's say x squared plus y squared equals r squared, and ax plus by equals 0. So the question here is, two curves are orthogonal if their tangent lines are perpendicular at each point of intersection, so that the given families of curves are orthogonal trajectories of each other. And I just picked one example. So they're asking us to show that these two families of curves. So what are they, first of all? Can anyone tell us what this is and what this is?
The first one is the equation of a circle, I believe.
Great job. And the second one is,
Is that one an ellipse? Or I mean, yeah. Yeah, never mind.
So power 1 cannot be an ellipse. It's a very good point. Even mistakes help us, okay? So the ellipse has to have x squared or blah, 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 x minus or plus, but squared, right? So whenever we see something like this with power 1, not 1 over x. 1 over x is not power 1. 1 over x is power negative 1. So this is a circle and this is a line. So they're asking us to, in this problem, to show whether they are orthogonal trajectories. These are two families of curves. Why? Because r can be 1, can be 2, can be 3, can be, and I can continue forever. So they're all centered at the origin. So they look like this for different r. Okay? So, and these are lines. And they're all lines that pass through the origin. So I don't know. I'm just graphing. So something like this. So at every point of intersection, I can show that the tangents are perpendicular. Therefore, these two curves are orthogonal trajectories. Okay, so how do we do this, first of all? I recommend the following steps. So my first step would be to show that they intersect or find points of intersection. So 1, find points of intersection. Okay, second step would be to find the derivatives, and so on and so forth. In a minute, we'll get there. So how do I find the points of intersection?